Imagine trying to build like a towering state-of-the-art skyscraper. You've got the blueprints, you have the materials, your vision is totally set.
You're ready to break ground.
Exactly. But before you can pour a single ounce of concrete, you're forced to spend, I don't know, 6 months petitioning the city for a zoning permit.
Oh, the red tape.
Right. You have to hire an expensive architectural firm, and then you're just waiting for these massive, heavy machines to be shipped across the globe. By the time you're finally allowed to start building, your original vision is just entirely bogged down in bureaucratic mud.
It's exhausting just thinking about it.
And that agonizing wait, that is exactly what data professionals experience every single day when they're trying to process massive data sets. I mean, you want to cook up some insights, right? But instead, you're stuck waiting on the IT department to provision a server or, install some incredibly heavy desktop software.
Well, today, we are basically tearing down that infrastructure barrier. We are jumping into a deep dive on the datok workspace.
Specifically, we're looking at their join and union suite.
Right. Because our mission today is to uncover how you can seamlessly merge, stack, and really orchestrate massive data streams locally. And the crazy part is you do this without ever leaving your standard web browser.
It's wild.
We are exploring this fundamental shift where the browser is no longer just like a window to the internet. It becomes a localized operating system.
And I'm bringing my perspective as someone who has spent over a decade in the data trenches. I'm Alex Martinez, and I've literally lived through the era of waiting hours for heavy desktop installers like Alteryx and Tableau just to download.
The spinning, loading wheels of doom.
Oh, don't even get me started. I've fought with license keys. I've begged IT for laptops with more RAM just to run a really basic ETL pipeline. So looking at datok's official documentation today and the screenshots of their visual interface, I bring a mix of extreme optimism, but also some very grounded realism.
Because you know how messy data gets out there in the wild.
Exactly. I've seen it all.
Oh.
And I also know a lot of data jokes that honestly only a really tired analyst would find funny.
I'll brace myself. And my background is as an educator. I'm Sarah Chen. I really focus on breaking down these complex software operations so that anyone can understand the underlying mechanics. When we examine these sources, we aren't just memorizing, what buttons to click.
Right. It's not a tutorial.
Exactly. We are unpacking the how and the why behind the actual architecture.
So let's start with that architecture, because before we can combine any data, we really need to talk about where this data is actually sitting.
Location is everything.
Yeah. The documentation states that datok is a browser-native web application, 0 software installations, 0 downloads. But here's the kicker. It executes 100% locally using the browser's OPFS. Now, I know what a traditional file system is, but what is the Origin private file system actually doing behind the scenes?
So OPFS is the technological breakthrough that makes this entire workspace possible. Historically, web browsers were, heavily sandboxed.
I think security reasons, right?
Exactly. A website couldn't just reach into your hard drive and read or write massive files rapidly. It had to rely on these really cumbersome workarounds like IndexedDB, which had severe storage quotas and, honestly, sluggish performance.
Yeah, totally unusable for real data work.
Right. But the Origin private file system changes that. It provides a secure, dedicated directory right on your local machine. Specifically, it usually lives in your C drive under users, your username, documents, and then the datok folder.
Oh, so it's a real physical folder on the drive.
Yes, it gives the web application high-performance byte-level access to read and write files almost as fast as a native desktop application.
Wow, so it bypasses the cloud entirely. I mean, that immediately solves a massive headache for corporate data governance.
How so?
Well, if I'm working with highly sensitive customer financial records, sending that data over the wire to some third-party cloud server usually requires like a 6-month security review.
Oh,
The
absolutely.
lawyers get involved, IT gets involved. But if datok is executing locally through OPFS, the data never actually leaves my physical laptop.
The privacy implications are huge. There are no bandwidth limits to worry about, there's no cloud latency, and no remote server costs. Your local hardware is doing all the heavy lifting.
Wait, but hold on. If the browser tab is acting as the engine, what happens when I hit it with a 50 million row CSV file?
The million-dollar question.
Because in my experience with heavy desktop tools, I have literally melted motherboards running multi-gigabyte joins that consumed like 32 gigabytes of RAM.
Yeah.
A web browser struggles when I have too many news articles open.
It's true.
Won't a serious data pipeline just exhaust the memory and completely crash the tab?
Yeah. That is the practical boundary of local browser execution. Web browsers operate using JavaScript engines like Chrome's V8 engine, which enforce a strict maximum memory limit for any single tab.
Right.
Depending on your machine, that heap limit caps out around 2 to 4 gigabytes. So yes, if you attempt to load tens of millions of rows into the visual interface all at once, you will exhaust that JavaScript heap.
Boom.
Yep, the tab will throw an out-of-memory error and it will crash.
Yep. Okay. Losing 3 hours of pipeline design because a browser tab crashed sounds like an absolute nightmare.
But here's the clever part. The pipeline design itself isn't lost.
Oh, it's not?
No, because the physical database files and your workflow logic are being continuously saved to that local OPFS directory we just talked about.
Yeah.
The data on your disk remains perfectly safe.
Oh, okay.
It's only the browser tab's active memory that overloaded. But obviously, you want to prevent those crashes from happening in the first place.
Definitely.
So datok relies heavily on downsampling. The documentation specifically points to the filter and sample size tools for this.
Ah, I see how that works in practice.
Right.
So when you are designing the pipeline, you don't actually need to see all 50 million rows to know if your logic is correct.
Exactly. You don't need the whole haystack to know if the needle looks right.
Right. So you just drop a sample size tool at the very beginning of the flow and you tell it to just grab, say, the first 1,000 rows. Or maybe just a 1% random sample. And then you build the entire complex web of transformations using just that lightweight footprint.
Precisely. Downsampling keeps the memory footprint well under the browser's limits while you actually do the work. And then once the pipeline logic is perfectly dialed in, you just remove or disable that sample tool, and you execute the final output directly to the disk.
So it bypasses the visual interface at that point.
Exactly. The engine streams the data through the logic and writes it to the OPFS directory without trying to render all 50 million rows visually on your screen at once. It's a really highly efficient workflow that respects your hardware limits, but still delivers enterprise-grade power.
That is seriously smart. Okay, so now that we understand the kitchen we are cooking in, let's talk about prepping the actual ingredients.
A fun part.
The most common hurdle in any data project is taking two completely separate tables and bringing them together side by side. The datok documentation introduces the join streams tool for this. You feed it a left table, say a list of customers, and a right table, like a list of sales. And you tell the tool to match them based on a common key, like customer ID.
The horizontal merge. I mean, this is a foundational concept in relational databases, but the visual execution here is really what stands out in the documentation.
Yeah. People often use a zipper analogy for this, like the two tables are the fabric, the match keys are the teeth, and the join tool zips them together.
It's a classic analogy.
It is, but I've always hated it.
Really? Why?
Because if a real zipper has broken teeth, the entire thing gets stuck and the jacket is ruined. Data doesn't work like that, or at least it shouldn't. I prefer to think of the join streams tool as a complex train yard.
Okay, I like this. Let's follow that train yard visual.
So you have two trains arriving at the station. One is carrying your customer data. The other is carrying sales data. The join tool acts as the automated switching yard.
Tracking so far.
It looks at the ID numbers on the cargo cars.
Yeah.
When it finds a matching pair, say customer 101 and a sale for customer 101, it couples those cars together and sends them down the main outbound track.
And that successfully coupled train is what we call the inner join.
Exactly. It's the perfect seamless union of the two data sets.
But in a perfect world, every single car on both incoming trains would find a match. But as we both know, real-world data is inherently flawed.
Always. It is a guarantee. You will inevitably have a sale in the system for a customer ID that was entered with a typo. Or, a customer who recently signed up but just hasn't purchased anything yet.
Right.
Those are the uncoupled cars. And this is where legacy data tools often create a total nightmare scenario.
Because of the silent failures.
Yes. And a lot of older SQL-based systems, or even just basic spreadsheet lookups like VLOOKUP, if a record doesn't find a match, it is just silently dropped from the final output, or it just returns an ugly error.
Yeah.
You might not realize you just lost 20% of your quarterly revenue data just because someone put an extra space after an ID number.
Silent data loss completely destroys trust in reporting.
It really does.
But datok addresses this through explicit visual routing on its Site-Escape canvas.
The Site-Escape canvas, that's the visual node graph.
Exactly. Site-Escape is actually an open-source network visualization library. It was originally designed for mapping complex biological and genetic networks.
Oh, wow. I had no idea.
Yeah. So it is incredibly effective at handling chaotic webs of information. In the datok UI, the join strings tool doesn't just output the inner join, It provides three distinct mandatory visual output ports. You have the inner join, the left unmatched, and the right unmatched.
Returning to the train yard analogy, those unmatched ports are basically the side tracks.
Right.
The unmatched cars don't derail the main operation. They are gracefully switched onto these dedicated side tracks so you can go inspect them. It forces transparency.
Proactive auditing is built right into the design. You are forced to acknowledge the data that fell through the cracks. You can immediately attach a visual browse node to those unmatched ports, look at the underlying rows, and investigate exactly why they failed to couple.
That's huge.
It really changes the entire posture of the analyst from reactive troubleshooting to proactive data governance.
Okay, so bringing in new columns side by side with a Dival, join solves a massive piece of the puzzle. But inevitably, time passes. You finish January's reporting, and February rolls around.
And you need to update the data.
Right. You don't want February's sales data glued to the side of January's data. You want it stacked directly underneath. So we move from horizontal merging to vertical stacking. For that, Datok provides the union streams tool.
The union operation. It takes multiple incoming data streams and literally stacks them vertically into a single, unified, tall data structure.
Sounds simple enough.
It does. But the complexity arises from how the tool actually decides which columns align with each other during that vertical stack. The tool offers two primary configuration options for this matching columns: auto by name or manually by position.
Well, auto by name is the dream scenario.
Oh, absolutely.
You just tell the tool to look at the column headers.
Hmm.
If January's file has a column called revenue and February's file has a column called revenue, the tool just seamlessly stacks them on top of each other. It sounds flawless until you hit the real world.
What usually happens?
Specifically, the finance department changing their spreadsheet templates without telling anyone.
Schema drift. It is a constant battle.
Yes. In the real world, January's file calls it revenue, right? But February's file calls it rev, March calls it total_rev, and April just has a column literally titled money.
Because why not?
Right. If you use auto by name there, the tool sees four completely different column names. It creates four separate disjointed columns, leaving these massive empty gaps in your final data set. The pipeline completely collapses.
This is exactly why the manually by position option is such a critical safety net. When you configure the Union Streams tool to map manually by position, you are basically instructing the engine to completely ignore the text in the column headers.
So it just looks at the layout.
Exactly. It forces the data to stack based strictly on its physical structural order in the file.
Column 1 stacks on column 1, column 2 on column 2, regardless of whether someone typed revenue or money.
Right.
It allows you to override human inconsistency. I honestly cannot overstate how many times a feature like this saves a production pipeline from failing at, like, 3 in the morning just because the lazy data entry clerk decided to abbreviate a header.
It goes back to that grounded realism you talked about earlier.
Yeah.
The software assumes the data will be messy, and it gives you the specific lever needed to bypass the mess.
So we have robust solutions for connecting two tables horizontally and for stacking them vertically. But enterprise data models are rarely just two files.
No, they are usually intricate webs of relationships.
Exactly. You might have a central sales table, but you need to connect it to a products table, a customers table, a geographic regions table, and maybe a date dimension table.
All at once.
Right. So what happens when my train yard needs to coordinate 5 different trains arriving from 5 different directions all at the exact same time? In older desktop tools, I would solve this by daisy chaining standard join tools together.
Oh, the waterfall method.
Yep. I would drop a join tool onto the canvas, connect the sales and customers tables, and configure the keys. Then I take the output of that first join, drag a second join tool onto the canvas, and connect it to the products table. I'd repeat that process until I had this massive waterfall of individual two-way connections.
Sounds tedious.
Very. So why should anyone bother learning Datok's join multiple tool when that old daisy chain method technically achieves the same result?
Well, the answer lies in cognitive load and mathematical precision. Let's look at the visual impact on that site escape canvas first. Daisy chaining 5 tables requires 4 separate join nodes. And as we established, each of those nodes produces an inner join, a left unmatched, and a right unmatched output.
Right, the sidetracks.
Exactly. If you are auditing your data properly, you are routing all of those unmatched streams somewhere. Your visual node graph rapidly deteriorates into a chaotic, unreadable spaghetti bowl of crossing lines and cascading nodes.
Which is an absolute nightmare when you have to open that same workflow 6 months later to figure out why a metric is slightly off. You want to understand the architecture at a glance, not trace a maze of overlapping lines with your mouse to decipher the logic.
The Join Multiple tool cleans up that visual clutter dramatically. It allows you to connect 3 or more streams simultaneously into a single, unified operation.
So just one node.
Just one. You have 5 lines going into one consolidated node and a clean, predictable set of lines coming out. You declare the match column names across all of the input streams in one central configuration window. It drastically reduces the cognitive load required to understand the pipeline.
Okay, that makes perfect visual sense. But you also mentioned mathematical precision. How does joining them simultaneously actually change the underlying math?
It really comes down to how you handle the outer boundaries of the data. The Join Multiple tool supports both inner joins and full outer joins.
Let's actually define a full outer join really quick, because it's a concept that often trips people up.
Good idea.
While an inner join only keeps the records that match perfectly across the tables, a full outer join basically says, I want to keep every single piece of data from every single table, whether it matches or not. Where there are matches, it lines them up. Where a record is missing data from another table, it just fills that empty space with a null value, but it never drops the row.
All right. And implementing a full outer join across 5 tables using a daisy chain of two-way joins is mathematically perilous.
Perilous. How?
You have to meticulously manage the unmatched records at every single step, unioning them back into the main flow, or you risk dropping data prematurely. For instance, a customer might not exist in the sales table in step 2, but they do exist in the support ticket table in step 4.
Oh, I see.
If you drop them in step 2 because they didn't match, you lose their support ticket data later on.
You essentially filter them out of existence before they even have a chance to match further down the line. It's kind of like trying to coordinate a complex dinner party by calling 5 different friends individually and playing a massive game of telephone.
That's a great way to put it.
Someone is going to get the wrong time, or someone is going to be left off the final guest list entirely by accident.
Exactly. But the Join Multiple tool acts as the group chat. It evaluates all the relationships across all the connected tables simultaneously. It keeps the entire universe of your data intact, from the first step to the last, ensuring that no record is accidentally dropped due to the sequential order of operations.
It centralizes the logic.
Right, making the pipeline mathematically cleaner and significantly less error-prone.
So stepping back, what does this actually change about your day-to-day workflow? We've covered some incredibly dense mechanics today. The Join and Union Suite inside Datok empowers you to perform serious, enterprise-grade data modeling. You can seamlessly zip complex tables together, you can audit the unmatched records proactively, stack messy files by positional mapping, and orchestrate massive multi-table webs with a single node.
That's a lot of power.
It is. You are doing the kind of heavy lifting that just a few years ago required a dedicated desktop installation, a very powerful CPU, and a specialized IT setup.
The fundamental math behind a join or a union hasn't really changed. The real breakthrough here is the accessibility in the architecture. You are executing these complex transformations completely locally, utilizing the origin private file system to bypass the cloud entirely straight from a standard web browser.
Which is still just crazy to me.
You don't have to wait on IT approvals. You don't have to compromise your organization's data privacy by sending sensitive information to a third-party server.
It is basically the industrial kitchen materializing exactly when and where you need it, and then vanishing the moment you close the tab. You just bring your messy real-world data and you start cooking immediately.
Which leaves us with a pretty critical question about the future of data infrastructure. If a standard web browser, securely leveraging a local file system, can now orchestrate massive multi-table data joins and handle millions of rows with zero latency,
Yeah.
what does the future hold for traditional heavy desktop software?
Oh, that's a great point. Are we watching the beginning of the end for the download and install era of data analytics? Think about that the next time you are staring at a progress bar, waiting an hour for a bulky software update to finish installing just so you can combine 2 spreadsheets. Keep pushing the boundaries of what your browser can do, and we will catch you on the next deep dive.